Hello everyone, and welcome to our follow-on video from the previous video on elastic collisions. In this video we will be doing inelastic collisions. Alright, so first of all we begin by defining what is an inelastic collision. An inelastic collision is a collision in which total momentum is conserved, but total kinetic energy is not conserved. The kinetic energy is transformed from or into other kinds of energy such as heat. Alright, so let's look at how we can understand inelastic collisions a little bit more by looking through a worked example from the Ciavula textbook for grade 12. We're looking at worked example 14 in this video. Alright, which is an inelastic collision question. Consider the collision of two cars. Car 1 is at rest and car 2 is moving at a speed of 2 meters per second to the left. Both cars have a mass of 500 kilograms. The cars collide inelastically and stick together. What is the resulting velocity of the resulting mass of metal? Alright, let's look at how we should approach this question. Always step 1, let's draw a rough sketch of the situation just to find out and to see what we are looking at over here. And over here we have drawn the collisions for you. Alright, so car 2 is moving but car 1 is stationary. They collide and stick to each other. So if a moving object collides with an object standing still with the same mass but the velocities differ, the stationary object will in fact move after the collision. Step 2. Let's determine how to approach the problem by writing down what we have been given. The mass of car 1 is 500 kilograms and so is the mass of car 2. M1 and M2 denoting the masses of the two cars respectively. The initial velocity of car 1, VI1, is 0 meters per second. The initial velocity of the second car, VI2, is 2 meters per second to the left. The collision is inelastic. So all of the information we have given, we have written down into 5 points. Now all the quantities are in SI units, in other words, they're in the correct units. And we are required to determine the final velocity of the resulting mass, in other words, Vf. Since the collision is inelastic, we know momentum's conserved. Alright? So we know that m1 vi1 plus m2 vi2 is equal to m1 vf1 plus m2 vf2. Alright, which is equal to m1 plus m2, alright, bracketed times vf, because all we want is just the final velocity of the resulting mass. In other words, of the two cars together. So we know that both cars are 500 kilograms each, so if they are together and they stick together, the total weight will be 1,000. Hence, the formula here at the bottom, alright, right there, m1 plus m2 bracket all multiplied by Vf. And we know that kinetic energy is not conserved. Now because car 1 is stationary, in step 3 we will choose left as our positive direction because car 2 is the object that's moving. So it makes sense to choose left as positive and not right as positive because there's no right movement at all. So step 4, we need to solve the problem. Law of conservation of momentum. PTI is equal to PTF. Alright, and as we sub it into our formula here, 500 times 0 plus 500 times 2 is equal to 500 plus 500 times the final velocity. Alright, 1000 is equal to 1000 VF. Alright, and that means that Vf is equal to 1 meter per second. Therefore, the final velocity of the resulting mass of the cars is 1 meters per second to the left. And that makes perfect sense because car 1 was stationary, car 2 was moving at 2 meters per second. They collided, and the car 1 only moved 1 meter per second to the left in the same direction as car 2 was moving. Alright, a very simple and straightforward question. Let's go have a look at how to do an exercise answering elastic and law of conservation and inelastic collision questions. Exercise 2.4. Alright. So question 1, a truck of a mass of 4,500 kilograms is traveling at 20 meters per second, and that hits a car from behind. The car with a mass of 1,000 kilograms was traveling at 15 meters per second. The two vehicles are now connected, and they carry on moving in the same direction. A. Calculate the final velocity of the truck-car combination after the collision. Alright, well, first of all, A, what have we been given? Alright, I believe the mass of the truck was 4,500 kilograms, so I'm going to write that as M1, 4,500 kilograms. Alright, and M2 was 1,000, oops, not 1,000 rand. That was 1,000 kilograms. Alright, and I do know that VI1 was 20 meters per second. In other words, that was the speed of the truck initially. VI2 was 15 meters per second. Alright, because that was the mass of the car. And they want me to calculate VF. Alright, in other words, the final velocity of the truck-car combination. Well, over here we know my formula, PTI, was equal to PTF. And I know that M1 VI1 plus M2 VI2 must be equal to my total final momentum, which in this case will be M1 plus M2 multiplied by VF. Now, please understand this side of the equation. The truck and the car are connected, so their masses will be taken into account and added together. I want the final velocity of the total system, in other words, the combination of them both. Alright, so I'm not looking for the final velocity of the car or the truck. I'm looking for the final velocity on a whole of both of them. Alright, so let's sub in our values. 4,500 multiplied by 20 meters per second plus 1,000 multiplied by 15 meters per second equals to 4,500 plus 1,000 VF. Alright? So to get VF on its own, we can just multiply by or divide by 4,500 plus 1,000, which we know is 5,500. Alright? Those cancel. And then we have 4,500 plus 1,000 here at the bottom. Bracket that up. Alright, now what we can do is we can put this whole side in onto our calculator. And if we do that, we will get an answer of 19.09 meters per second. Right, there is our answer. Perfect. Alright, that is the first question done.